All right, so recording has begun. A few persons reached out and wanted to clarify some of the stuff here. I thought it prudent just to use today's session to have a look again at some of these subnetting problems. Please mute your mics. And then during the week, I put out some videos, read the other set of content that we need to cover. Most of what we have left is really theoretical based. So you can watch those videos when they come out, and then we can talk about them. Please also remember that you are in preparation mode for 2 additional tests. So bear that in mind as well. So I think someone had asked about the last question. Compute the maximum number of valid subnets and usable hosts per subnet that you can get from the network 192.168.146.0 with a /27 side annotation. So I'm assuming that some of you would have actually tried that, so you have some information that you want to give. So who want to talk about that one?
All right, so in regards to that, sir, for the valid subnets that are the valid subnet or networks that we could create from that one in respects to the information that's there, sir. That would be a total of 2 to the power of 3, which is 8. So we could create 8 different networks, sir, or subnets.
All right, so how you come up with that?
Because we borrowed 3 bits from the 4th octet.
Okay. So this is a Class C IP address.
Yes, sir.
All right, good.
Class C. So we would end up with a 24
By default.
by default, sir.
But we are using /27, which means that we are turning on the first 3 bits.
Yes, sir.
And it means the other bits are going to be 0.
Yes, sir.
So because we have turned on 3 bits for subnetting, then to know how many subnets we are going to set 2 to the 3, and that gives us 8. So you are correct, we have 8 subnets. Now, a subnet is going to have some IP addresses associated with it. So now we need to
Yes, sir.
determine how many IP addresses are associated with each subnet.
So
So how we do that?
that would be the remaining bits that weren't turned on, sir, which would then be 2 to the 5, which is 16.
No, 2 to 5
2
is not 16. Look at the table, 2 to 5 is what?
32, sorry, sir.
So 2 to the 5 is 32. So we have 8 subnets. So let's say And we have 32 IP addresses. Now, you should remember that each octet has how many patterns in total?
Each octet has
No, an octet, just by default, an octet has how many patterns?
256, sir.
256, because there are 8 bits, 2 to the 8 gives us 256. So each octet comes with a total of 256 patterns. So if we're working in the last octet alone, fourth octet, and we are saying that we're going to use some of these IP addresses to represent networks, and we're using some to represent IP addresses within those networks, then what it simply means is that we're chopping up that 256 into different components. So we end up with 8 units or 8 sections or 8 rooms, and each of these rooms has a maximum of 32 IP address associated with it. So when we multiply 8 by 32, what we end up with?
256.
256. So we have accounted for all of the IP addresses. That's really what subnetting is. So we have 8 subnets, 32 IP addresses within each of the subnet. We do the multiplication, then we end up back with 256, which we know could be the number of patterns that we have within one octet. And we're just working with octet. Yeah, so
But sir,
that's it. So
It's usable
it was
IP,
saying
though.
usable host.
before,
It was saying usable host.
yeah,
So
man,
we
so
might
we're
have to
going to talk
do.
about that now. We don't finish that. I'm just making the point that we need to account for all of the IP addresses. And we have accounted for all the IP addresses. So we have 8 subnets. And we know that each subnet has a maximum of 32 IP addresses. So 8 times 32 gives us 256. So we account for the total range. However, as you rightly said, the question asks about usable host per subnets. So what do we know about usable host within a subnet?
The first and the last are designated IP addresses there. So the first one is designated to the network, and the last one is the broadcast.
There you go. So there are 2 out of each. There are 2 addresses out of each of the range, out of the possibilities, that are not going to be placed on any host. First and the last. First one will be used to represent the network or the subnet, the network ID. The last one is going to represent the broadcast address of that subnet. So therefore means that it's going to be 32 minus 2. So the number of usable hosts per subnet then is going to be 30. So the total answer is 8 valid subnets and 30 usable hosts per subnet. I trust that that is clear now.
Yes, sir, completely.
Okay, good. So who want to do the one above that?
All right. So it's /17. So the change is taking place in the 3rd octet. So the subnet mask would be 255.255 that 128. So the 128 is the increment bit. So if we're going up by 128 can go in 255 only in 256 only 2 times. So the last
Before you come to that, all right, 1 minute. So
okay.
let's follow out the subnetting, the octet that we're doing the subnetting in. So which octet is we're doing the subnetting in?
Third octet.
Third octet. So in that third octet, what is the pattern going to be? The binary pattern.
1
1
0 0 for everything
everything
else.
is going to be 0 0. So that is it. But remember, we're in the third octet. So it means that the octet after this is going to have what?
Zeros? Is that what you're asking?
Yes.
Everything
So
turn
the
on?
next octet, so the fourth octet is going to have 8 zeros. So this is what we're looking at, is the third octet. And we are saying how many network bits have we assigned for subnetting?
$17.
No, man. Network bits for subnetting.
Oh, 1 for
1.
subnet?
1. So it's 1 bit that we have turned on to represent subnets. If it is 1 bit that we turn on to represent subnets, then how many subnets do we end up with?
2, sir.
2. 2 to the 1 gives us 2. So dealing with 2 subnets. Good. Now we just spoke about the fact that each octet has how many patterns?
256.
256. So if we are looking at the total number of patterns that we're dealing with, talking about subnetting, the total number that we're dealing with, inclusive of those host bits, then how many patterns are we looking at total?
Right. Sir, would it be 32,768?
Going to be what?
You said the number of hosts that we're working with?
No, not the number of hosts. I want to know the total number of patterns. So let me backtrack. When we look at the previous one, the one down here, the /27, how many patterns total were we working for /27?
Oh, for just /27, sir?
For /27, how many total patterns were we working? Remember, we're subnetting that octet. So how many patterns in total did we have?
For /27,
Sir, because
I hearing
Alright, go ahead.
2 things.
I was about to say, sir, if it's for /27, you're talking about the bits, total for /27. Does it include the host or just the network, sir?
So let's go again. I want to know for /27 the total number of patterns that we were working with.
6,197. I think that's what I got.
No.
It was 256.
256. It was 256. And we chop up that 256 into 8 sections, where each section had 32 IP addresses. But the total pattern that we were working with is 2 to the 8, which is 256 patterns.
Wrong calculation with the sir.
So given that, I'm now coming back to this problem, where we are now doing the subnetting in the third octet. And I'm asking a similar question as I asked a while ago. Question is, how many total patterns are we working with?
Is it 512?
No, it's not 512.
Is it 1024?
No.
Sir, wouldn't it be the same 256 since we're in the third octet?
No, it's not the same 256. How many octets we're working with?
2, sir.
2 octets.
Oh,
So what's the total number of patterns if we're working
so
with 2 octets?
So one pattern would be 256, so 256 times 2.
No, that's incorrect. You're missing something very important. So the lucky thing we're having this conversation.
Sir, 160?
No.
What are we trying to establish exactly, sir?
How many patterns do we have if we're starting to do the subnetting in the third octet? How many total patterns are we going to divide on?
1, 2, 3.
Is it 16, sir?
No, that's the number of bits. I want the patterns.
well, each subnet would have 128 patterns.
No, I'm not asking about this particular problem. I'm asking a general question. So that when you work
Oh,
out this problem, you can check back to see if what you get really right.
so
But
just in general, sir, if we're starting in the third octet, how many
patterns.
patterns are there? So 255,
So
255.
2 to 16.
And 2 to the 16 gives you what?
65,536 patterns.
There you go. So we're working with 65536 patterns. So we're not adding them, we're multiplying them. So it's 256 times 256. By the way, somebody punch in 256 times 2.
So you're saying for each one in the third octet, we're getting another 256 from the fourth octet?
Yes, that's
Okay.
exactly what is happening.
Sir, 65,536.
Right. So 256 times 256 give us back the same thing as 2 to the 16, which is 6553. So that's the total number of patterns that we are working with. So given that, you know that when you finish, you must account for all of these. So now we're doing the subnetting. So with this one bit that is turned on in the third octet, how many subnets we end up with?
2 subnets, sir.
2 subnets. 2 to the 1 gives us. All right. What else do we know? And I think it was said earlier, but I'll ask again. What else do we know given that only one of these bits is turned on? What else do we know?
It means that 7 bits are assigned to the host.
That's not really true.
Not quite.
So how many bits are assigned to the host?
Wait, sir,
Huh?
is this a question?
So the
This is
7
a
plus the 8 from the fourth octet.
So
The
it's a
7 from
7
the
Yeah, I
plus
was
the
trying to
8.
I was trying to figure out if you're working from the third or the fourth octet. I wasn't sure.
Well, we're working from the third octet because that's where we're doing the
Yeah.
subnetting. But
Okay.
in order
Which,
to appreciate what is really happening, we have to factor in everything.
yeah, I know, sir, but which questions are we on? I joined late. Sorry about that, sir.
We are at the second to last question.
Second to last question. Okay.
So it is 2 to the 15. And 2 to the 15 gives us what?
So 32,760, sir.
Well, let me write that down. 32,000 what?
768.
768?
Yes, sir.
Okay. So 32,768. I am assuming that that is correct. I am not punching it in.
It's
So
on
if
the board. It's actually there, sir, on the screen.
so, actually where?
It's on the screen right there. 32,768.
Yeah, man, I just type it.
Oh.
Yeah, but I'm saying that I'm not punching it in. So I am assuming that whatever you give me is actually correct. So if when we work out, we're not getting back the total range, then it means that you do something wrong in your calculation. All right. So that's what we're working with, right? And how many subnets we have?
Two, sir.
2 subnets. So if we have 32,768 patterns in a subnet, and we have 2 subnets, and when you multiply that by 2, what we end up with?
65536.
Absolutely. And that makes sense, right? Because what have we done? We have taken the 65536 and we're creating 2 sections. So we're dividing it into 2, no so? Or we create 2 sections. So in a 1 section, we're going to have 32,768 addresses. And in the other section, we're going to have 32,708. So when we look back, realize that it's working out back to the full range that we have allocated. Hope this making sense, folks.
Yes, sir.
Okay, so it makes sense to one person.
Makes sense to me.
Persons. Oh, okay. All right, cool. So that's essentially what we are doing. All right. So the question is asking you for the valid host range for the network that a particular IP address happens to fall into. And the IP address that we're interested in is 172.26.25.17. Now, there's something else that was being said earlier about block size. What is the significance of the block? First of all, what's the block size?
Sir, is a block size the increment value?
Yeah, man, the block size or the increment value have different names. Increment value, block size. What is that? In this instance, what is it?
It tells how
No, just tell me what it is.
It says the
128, sir.
Tell me the value.
next range.
Tell me the value.
128.
128.
128. How do we know it's 128?
Sir,
Because there are
the
two
first.
networks. And
Ye-
you starting
yeah.
at 0 and 128
All right,
to
from the
256.
table, how do we know that is 128?
You're
Sir, in
going
the
after the
representative.
last bit that was turned on.
All right. I think that was Barnaby.
Yeah.
Yeah. So look at the last bit that was turned on. So it's only one bit is turned on. So because of that, we know that it's going to be 128. Now, what does this block size tell us? Or this increment, what does it tell us?
The starting to the next octet, starting
There
point
you
to the
go.
next range.
So it tells us when the next octet begins. In other words, the first octet here is going to be 172 dot, what's that? 26 dot 0.0. That's where the first one going to start. Because remember, we know that the first two things are going to remain consistent. The next one is going to be 172.26 dot, and now we're inside the subnetting octet. Because the block size is 128, or the increment is 128. We know that the other one going to start at dot 128.0. And we know we only have two. So it therefore means that this is the starting of one, and this is the starting of the other one. Oh, stay so far. Are we good?
Yes, sir.
All right.
Yes, sir.
So if this is the starting of the other one, then where this one end? Where the first one end?
172.26 at 127.
170 who?
Class.
172.
172.
That 26 at 127.0.
26. That what?
127.0.
127.0.
So that 255 or 256?
1 minute. I want to hear what him say first. He said that 0.
Oh, sorry, sir. My bad. No, it's not 0, sir. It would have been is it 255 or 256? I don't know.
No, you have to tell me which one.
I'm trying to remember. Let's see. Well, 256 would have been reserved for broadcast. So would it be 255?
So I say it's 255 because something is reserved for broadcast. But we go address
The
that.
last okay. Because if I remember, yeah, as I said earlier, so first address is reserved for network and last address is reserved for broadcast. So I was wondering.
So it ends at 172.26 at 127.255. No, it is not because 256 is associated for broadcast address, because there's no 256. Within an octet, what is the minimum value you can have?
0, sir. That's why it's 255. There are 256
Thank you.
in total, including the 0. Sorry, getting confused there.
Thank you. So the minimum value is 0. The maximum value is 255. From 0 to 255 gives you 256 patterns, because we're counting the 0 pattern as 1.
Understood.
Yeah. So the thing I want you to bear in mind, think about when we are counting a base 10. We start from 0 and we go to 9, because we have 10 symbols ranging from 0 to 9. When we reach 9, and now add 1 to the 9, we now end up with 10. But what does the 10 mean? The 10 means that we can't have another symbol in that position. So we zero it out. And then we take a 1 and we move it to the position to the left. So in other words, we have one group of 10 and no groups of 1. That is what 10 is. So in a similar manner here, once you reach 255, if you add 1 to that, then you're going to put on a 0 in that position and carry a 1 to the left. And if you think about that, then it means that if I add a 1 to this 255 here, it becomes 256, but we can't put down 256. So that last octet now becomes 0. And we carry a 1 to the left, meaning we're going to have 127 plus 1 give us 128, which give us about this value that is the starting of the next subnet. All right. So where does this one end? This subnet down here, where it end? Quickly.
172 dot
Dot
26.
dot 26. That's what you said?
Yes, sir.
Dot
255.255, sir?
255.255. Everybody agree with that?
Yes.
Yes, sir.
Because if we add a 1 to that 172.26.255.255, if we add a 1 to that, then what we end up with?
172.27.0.0.
Exactly, we end up with 172.27, which means that we are now in a different network, don't it? Because the network that we are working with is 172.26. So if we reach 172.27, it means that we're no longer subnetting. Because if we're subnetting with it in the same network, but we're chopping up the range. So once we reach 172.27, then that tells us that it's a total different network we're working with. And we start dealing with subnetting. All right, so now the question was, we need to state the valid host range. But we also want to know which, this IP address that we're looking at, 172.26.25.17, which one of these range would have fall into. And then once we know which one of these range it fall into, then we can now determine what the valid host range is. So which one of these subnets it would fall in?
Sure, the first one, the 172.26.0.0.
Exactly.
That first one.
Yeah, that's where it would fall. Because you should be able to see that 172.26.25 is less than 172.26.127. It's less than that. So it means that it must fall into that first subnet. And now we are being asked about the valid host range. So the valid host range going to be what?
172.26.0.1 to 172.26.127.254.
Good. Excellent. So that is the valid host range. Mute back your mic, please. Thanks.
And we can even go a little lower, we can.
Yeah. So that's it. Because we have now subtracted the 2 that we know we must subtract, which is the first one that represents the subnet. That's network ID. And the last one that represents the broadcast address for that particular subnet. Yeah. So that's what we end up with. Now, let me just do something quickly. 172.26.0. 0. How many IP addresses do we have here, sir?
256.
There you go, 250. And if it now changes to 1.0, then it means that we'll get another 256. And if it changes to 2.0, and of course the ending going to change. You understand what I'm saying? So if we change to 2.0, then we're getting another 256. Yeah. So when you bear that in mind, then if you do the calculations, 128 times 256, then that should give you 32,768, which means that you have now accounted for all of the IP addresses within that particular. Alrighty then. So I think, folks, that if you understand what has transpired here, then you should understand subnetting. Yeah, go ahead, Steve. And
Sure, are you finished working the questions?
yeah, mama, finished, cause
Question 5 was doing a number on me.
what is question 5? What, this one?
Yes, sir.
Oh, okay. All right. So tell me what you end up with. Talk me through it.
Sir, nothing. Because, all right, so what I understand is that they want us to split the network 50 times, right? Am I wrong?
No, you're right.
All right, so they want us to split the network 50 times, and they want us to get 960 hosts per each one of the 50 subnets, right?
All
But,
right.
oh, sorry.
This is nice. What, Shannon? You have a phone?
Ronaldo, please mute your mic.
Oh.
But what kind of threw me off was, I guess I was doing it the short way. I don't know. But I kept getting decimals and,
No.
like, okay,
I'm getting a
exactly.
decimal.
So,
So
yeah,
what
I need
I
that.
guess what you were trying to do is to get an exact 50.
So that's what I realized, that it didn't give an exact 50, but I didn't know if that was wrong or not.
So you can't get an exact 50.
Okay, all right, and that's the case, then we
Because
got it. But still work it out.
we're in base 2. All right. So what you want to do is you want to find the minimum number of bits that you need that can give you 50 subnets. So how many bits would you need?
All right, repeat your question, please.
You need to find the minimum number of bits that you can have that can give you the 50 subnets. So how many bits would you need? In other words, you know what? Tell me what the subnet mask going to look like.
Okay, so because it wanted, hold on. I'm trying to remember what I did here. 1 second, please, sir.
So when she answers, I'm gonna propose something to you about how we can calculate this easily, and you can make
You're
it
going to
correct or not.
propose a.
No, I'm saying, sir, I worked out that question differently, so I was wondering if I could give it to you after she gives you her answers, so I can see if it's a valid way of working it out as well.
Okay, cool.
All right, so the subnet mask would be 255.255.0.0.
Sorry, just tell me what you're going to have here, so we can see what is turned on and what turned off.
I don't remember. I don't know.
All right, let me ask another question. How many bits do you need so that you're sure you can get 50 subnets?
8 bits.
Isn't 8 bits too much? You want 50?
Yeah, so that's the thing.
Yeah, so you want 50. So what's the minimum number of bits you can
Oh,
use that you're sure
2,
you can get 50?
2.
And if you have 2 bits, you can get 50 subnets.
Are you asking like in the third octet, sir?
It no matter which octet. The
Well, 2
question
to the
I'm
power
asking you now don't matter
64.
which octet. I want to know how many bits do you need for subnetting to ensure that you can have 50 subnets.
All right, I'm gonna say 7 bits because 2 to the power 7 is 64.
Here you go.
7.
Yeah.
You mean 6?
2 to the 6.
Oh, sorry, 2 to the 6. Yes.
Yeah, sorry about
Yeah.
that.
My bad. 2 to the 6.
Yeah, you're good.
Yes. But 2 to the 6 is 7. 1, 2,
What?
3, 4, 5, 6, 7. Yeah. It was correct.
Sir, I don't understand what you just said. You said 2 to the 6 is 7? I'm confused.
No, he's saying 2 to the power 6 is a 7th bit.
Okay.
Yeah, that clear?
Yes, sir. Yeah, so similar to what you were saying, what I did, sir, I didn't really look at the 960 hosts per subnet. I was just looking at the first part where it said, okay, 50. And I was saying, okay, 2 to the 5 does not give me 50, but just raise
Hold
it
on.
up to the
You
6 and say, okay,
you kind
64.
of break up. Go again.
Are you hearing me now, sir?
Go ahead. Talk. Say
I
it
was
what?
saying, the way I worked it out, sir, I was focusing on the part where it says where you just need to have 50 subnets. I figured the host per subnet would come once I cleared the 50. So I was saying, okay, 2 to the 5 is not enough. 2 to the 5 doesn't give
Exactly.
me 50. 2 to the 5 is
Exactly.
32. So I just say 2 to the 6 gives me 64. I say, okay, that's
Yeah.
good.
Yeah. And then you will realize that you have a bit more hosts that you're playing with. So it won't be 960 hosts.
Okay, that was my
Yeah,
problem, sir,
Yeah,
because
it will be a little bit more.
exactly, because
But what you are sure about is that you can get 50 subnets without wasting too much. Because if you go to, let's say, 128, you'd be wasting too much, right? 2 to the 5 can't do it. You agree? Because that's 32. True? 2 to the 6, that's
yes, sir.
64. So that's more than the 50. 2 to the 7 is 128, which is even more, much more than the 50. So you wouldn't want to go that far. So you want to go to the minimum number of bits that you can use to satisfy your subnetting needs. And once you do that, then whatever number of host bits are going to be left over, you just simply use them because based on the question, it should still fall into place. All right. So that is us then for the evening, folks. I will upload this as soon as it becomes available. And please look out for the other videos that I'm going to be putting up for the additional theory stuff that we need to round out the course. And please
Yes,
remember
sir.
to start
Definitely.
studying for the next test. Right?
you said it's 2 more tests.
Yeah, man, 2 more tests.
Sir, can you give us an idea of when you'll administer test 2?
So it won't be next week because of the I must put this. It going to be the weekend of the 6th and the 7th, that weekend. So remember, we
Okay,
have
thank you,
holiday
sir.
Friday, and then you have holiday Monday, so I won't soon a Monday. But on that weekend coming, yeah, that's when you get test 2. So I'll put something up on the side so that you can know what I expect you to know for that one. Alrighty?
Okay, sir.
So stop share. I'm going to stop